Hi, everybody. This time we're going to talk about how do you calculate the percent by mass of one element versus another in a chemical compound. Now, you actually have some experience with the results of this if you've ever looked at a food package. If it says something like what percentage of the contents is fat, or what percent of the contents is sugar, or dietary fiber, or protein, somebody has to figure that out. And a dietitian might do that in a laboratory. Well, chemists want to know that for each individual compound they're working with. Now, these calculations of mass percentage are very important in a whole variety of fields, not just having to do with food and nutrition. If you're talking about water and air quality, and you want to know the purity of whatever you're working with, that is very, very important. Manufacturing process, they need to know down to the parts per million very often of exactly what is going into the product they're creating. If you are going to start mining for gold in your backyard, you want to have a pretty good idea of how much gold is there, whether it's even worth your while, or if you're just digging up a lot of dirt for giggles. In an experiment, we need to know what's the chemical composition of our before and after product and results. And if scientists are going to chemically analyze anything, any sort of a drug or compound, this is a very common calculation. So this is a percentage, and you have calculated percentages ever since elementary school. The basic formula for calculating a percentage is this. You take the part divided by the whole times a 100 to make it a percentage. So I tried to find kind of a simple, fun thing for us to calculate percentage on, and I found this photo online, and I'm amazed that this pet parent managed to get all of her pets or his pets to line up beautifully. But I want to calculate what percentage of this collection of critters happens to be cats. So we're going to use this calculation. The percentage is equal to the part divided by the whole. So it's going to be the number of cats divided by all of the critters that are present. So first off, let's count how many cats we have. 1, 2, 3, 4, 5, 6, 7, 8. If I go along, 9, and I think that's all of the cats we have. Now, how many total critters are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 critters. Multiplied by 100 to take it from being a decimal to being a percentage. When I threw this in my calculator, I got 52.94%. Now you might say, Mary, how do you start with a 9 divided by a 17, 1 digit, 2 digits, and end up with something that many significant digits? Well, these are counting numbers which have an unlimited number of significant digits. When we're dealing with atomic masses and things like this, throughout this course, we very often have been using 2 points behind the decimal, so I want to keep that kind of similar flow as we go through these calculations. And I'm still incredibly tickled with this picture. It makes me smile. So let's do a chemistry example. What percentage of the total mass of water is due to the mass of hydrogen? So we're going to go back and we have to find that molecular mass of hydrogen. Of water. Water is H2O, so that means 2 hydrogen atoms and 1 oxygen atom. We're going to look on our periodic table for those atomic masses. Hydrogen's mass from right here is 1.01. Oxygen's mass is 16 atomic mass units. So this is going to be 2.02 plus 16. That's going to give us a total mass for water of 18.02 atomic mass units for a water molecule. Now, to calculate the percentage mass that is hydrogen, our percent is going to be the part, which is hydrogen, divided by the whole. The whole is the entire water molecule, times 100 to make it a percentage. So the mass of just hydrogen is 2.02. The whole is the 1802 times 100 to make it a percentage. And when I did that calculation, I ended up with 11.21%. Now here's a question for you. What if somebody said, aha, now that you have this done, what percentage is oxygen? Well, there's only 2 elements in this compound, so whatever is not hydrogen has got to be oxygen. If I take 100 minus 11.21, the remainder, the 88.79%, the remainder of that compound's mass has got to be due to the other element involved, which is oxygen. Let's do another one. And if you think you've got this, go forth and try it on your own. If not, let's do it together. So I'll let you kind of decide how confident you feel. What percentage of the total mass of iron 3 oxide, Fe2O3, which is common rust, is due to iron? Again, we're going to take this Fe2O3, so that's going to be 2 iron atoms plus 3 oxygen atoms. When I look on the periodic table, atomic mass of iron, I read that to 55.85. 3 oxygen atoms rounded off to 2 digits is 16. So this ends up being 11170 plus 48. Add those together and I get a total of 159.7 for iron. So I want to know the percentage of just iron out of the whole. So this is going to be the part, which is iron divided by the whole, iron 3 oxide times 100. So the iron portion is 111.7. The whole is 159.7 times 100. And when I did that, I got 69.94%. Okie doke. If you had one of these on a quiz, could you do this? Probably. If you think you got it, grand. If not, or you feel a little insecure, let's do one more. And for this one more, here's my question. There's another form of iron oxide, iron 2 oxide, which is this lovely aqua blue color. And let's figure out what's the total percentage of iron in this compound. Hit pause, try this, and then we'll do this together. So FeO is 1 iron plus 1 oxygen. And I'm just going to put an OX so it doesn't look like a 0. 1 iron is 55.85 and oxygen is 16. The total for iron oxide, iron 2 oxide, then is going to be 71.85. The percentage is going to be the part, iron divided by the whole, FeO. The part is 55.85, the whole is 71.85, times 100 to turn it from a decimal into a percentage, and that gives me 77.73% iron. Here's a question, chemistry question. If you were a miner and you had 2 possible sources, would you want to use iron oxide as your ore with a 77% iron, or would you want to use iron 3 oxide as your ore with only 70%? Yeah, you'd probably want to use the iron 2 oxide as your ore. The challenge is this is only produced in a low oxygen environment and is rarer on the surface of planet Earth. Iron 3 oxide, much more common on the surface of the planet, and hence tends to be a lot more of the iron ore that we see. All right, that will do it for this time. Bye-bye.